Hello and welcome to the 7-6 Notes. This is a section called Similarity Transformations. And the most popular transformation that deals with similarity is something that's called a dilation. So dilation. Okay, and this is a transformation that makes a figure larger or smaller proportionally. Okay, so the example that I have for you, that you're probably most common with is at the eye doctor. Okay, the eye doctor. And what the eye doctor does is it will dilate your eyes. Okay, and they do that because they want to look into the black part of the eye and just check for certain property or certain things that are going on with your eyes. So that means, and when you dilate your eyes, that means that the black part, the center, the black part, gets bigger or smaller depending on the amount of light, okay, that it wants to pass through, depending on the amount of light. Okay. So, what I want to talk about here, with a dilation, we say that it makes a figure larger or smaller proportionally. So we do have to deal with a scale factor. Okay, so with a scale factor. Okay, and so we were going to call our scale factor the variable k. Okay, so if k is less than 1, then the dilation is a reduction. Okay, and when we say the word reduction, we mean the word that it gets smaller. Okay, and if k is greater than 1, okay, if k is greater than 1, okay, then the dilation is an enlargement. Okay, and that means that it gets bigger. So let's take a look at some examples here, and let's take a look at numbers 1 and 2, and it says, determine whether the dilation from A to B is an enlargement or reduction. Okay, then find the scale factor of the dilation. So what we need to do is take a look and say, all right, if A is our image, or is our pre-image, and B is our image, okay, this is where we start, and this is where we end up. The transformation from A to B, does it get larger or does it get smaller? Okay, and so it gets bigger, okay, it gets larger, so we're going to call that an enlargement, okay, enlargement from A to B, okay, but then we need to come up with the scale factor, okay, the scale factor. And so the scale factor is just some ratio, okay, and I'm going to come over here, I'm going to start with A, and I'm going to label this side with a red line and call this 3, okay, and then I'm going to label this corresponding line down here with a blue line and call that 4, okay, and so because we have an enlargement, all right, because we have an enlargement, we know that our k value, our scale factor, needs to be that k needs to be greater than 1. So I'm going to say that k is greater than 1. Okay, So the ratio of these numbers that we would use, okay, if you did 3 divided by 4, that would be a number that's less than 1. But if we did 4 divided by 3, then that would be a number that's greater than 1. So our scale factor is going to be 4/3. Okay? Because that number is larger than 1. It's 1.3 repeating. Okay? Let's take a look at number 2. Okay? Now number 2, okay, if we take a look at the triangle for A, we notice that it's larger than the triangle for B. Okay? So from A to B, we're going to call this a reduction. Okay? A reduction from A to B. Okay? And we need to label our scale factor. Okay, and because we're dealing with a reduction, we know that our scale factor, that value for K, needs to be less than 1. Okay, so what I'm going to do is I'm going to go ahead and label one of the lines on part A with red, and I'm going to call this 4. Okay, I'm going to call the other one here on B, label that blue, and that's a length of 3. Okay, and so my scale factor, because it has to be less than 1, I need to think about a ratio using these two numbers that will be less than 1. And so if I take 3 divided by 4, that will give me 0.75, which is less than 1. So that's what I'm going to choose. I'm going to choose a scale factor of 3/4. Okay. So your scale factor is just a ratio of numbers. Okay. And so now what I want to do, I want to take a look at parts 3 and 4. I'm going to graph the original figure and the dilated image. Then we have to verify that the dilation is a similarity transformation. So what I'm going to do here is I'm going to go ahead and plot points for A, B, and C. So I'm going to go do -3, +4. Okay, I'm going to do the point 3, 4. And then I have the point -3, -2. Okay, and I'm going to connect that with a line. Okay, this is nice and neat. So now here's what I've got. Okay, I'm going to call this A, B, and C. Okay, and then I'm going to plot the other ones. I'm going to plot A prime, B prime, and C prime. So I'm going to do -2, 3. Okay, I'm going to do 0, 3. And I'm going to do -2, 1. Okay, and so I get this much smaller triangle here, and I'm going to call this A prime, B prime, and C prime. Okay, and what I'm going to do is I just need to verify that these two triangles are similar, and how do I know that? And so here's what I'm going to do. I'm going to go ahead and label this length here with that distance, okay, and this is 1, 2, 3, 4, 5, 6. So I'm going to call that 6. And I know that this is a length of 1, 2, 3, 4, 5, 6. So I'm going to label that as 6. And I know that this is a right angle here, okay, because, I've got a horizontal line and a vertical line. And then I'm going to do the same thing over here on the blue triangle. I'm going to call this a 2 by 2, and this is a right angle, okay. So I know this, okay. I know that angle A is congruent to angle A prime, okay. And let's take a look at segment AC, all right, and let's see if that's AC and AB, and let's see if that's proportional with A prime, C prime, and A prime, B prime. So I'm going to set up a proportion here and take 6, so this length here divided by 2, okay, and make sure that that's equivalent to this length 6 divided by 2, which we're pretty sure is correct, okay, 6 over 2, 6 over 2. But I want to just cross multiply and verify, so I get 6 times 2 is equal to 6 times 2. So we get 12 is equal to 12, so we're good on that. And so we know that they're similar, and I'm going to say this. I'm going to say that triangle ABC is similar to triangle A prime, B prime, and C prime by side angle side. Okay, and this is what I'm looking for as far as a similarity statement goes. So, all we did was say that two sides and an included angle. The angles are congruent, but the sides are proportional. And so that's all I need to do. Okay, let's try and take a look at number 4. And so let me verify this. Let me plot points for f, g, h, j, and so I've got -3, 4. I've got 2, 4. I've got 2, -2. And I've got -3, -2. Okay, I'm going to call this f, g, h, j. Let me connect my lines. And let's go ahead and do the same thing for f prime, g prime, h prime, j prime. So I've got -1.5, 3. Okay. And then I've got 1, 3. And then I've got 1, 0. Oops. 1, 0. And -1.5, 0. Okay. And so I'm going to go ahead and do this. I'm going to go ahead and connect those points. I'm going to call this f prime, g prime, h prime, and j prime. Okay. And I'm going to go ahead and call this a length. This is a length of 3. This is a length of 3. This here is a length of 2.5. So I'm going to do 2.5 there. And then I'm going to call this 2.5 down here. And then I'm going to go ahead and do the same thing for FGHJ. So that's a length of 1, 2, 3, 4, 5. Okay, that's a length of 5. That means I have a length of 5 down here. And then I'm going to go ahead and do FJ, which is a length of 6. So 1, 2, 3, 4, 5, 6 on this side and on this side. Okay, so because I have a rectangle, because FGHJ is a rectangle, I really only need to show that one pair of sides is proportional. So I'm just going to use FJ, F prime J prime, FG, and F prime G prime, because all the other ones would be congruent. So as long as I say that this set of segments is proportional to that set of segments, then we're good. So I'm going to do this. I'm going to do 6 over 3, okay, is equal to 5 over 2.5, okay? And then I'm going to multiply these together, and so I'm going to end up getting 3 times 5. Is that equal to 6 times 2.5? All right, and 3 times 5 is 15. And then 6 times 2.5, okay, 6 times 2 is 12, and then 6 times a half is 3, and 12 plus 3 is 15, so I get 15. And so that's true, okay? And so I know this. I know that quadrilateral FGHJ is similar to quadrilateral F prime, G prime, H prime, and J prime, okay? And I just said because, all the sides are proportional. So that's pretty much it. It's kind of easy to do, and it's just something that, we need to be able to just take a look at a pair of figures and be able to plot them and find the corresponding sides and do what we've kind of been doing to figure out if things are proportional. So hope you enjoyed this video, and go ahead and get started on the homework. Thanks. Bye.